Hello, everyone. We'll get started in just a minute as everyone joins this Zoom call. We are doing this in webinar format, so all the participants will be muted to avoid background noise, but you are welcome to ask questions using the Q&A icon at the bottom or side of your screen, depending on how you do your Zoom. Well, thanks everyone for coming, and we're very excited to talk to you about the new tools that I2SL recently released through our Labs2Zero program, and we'll hear about them now from I2SL's president, Gordon Sharp, and our Labs2Zero program director, Alison Farmer. Take it away.
Great. Thanks, Kathleen. So yeah, today we're going to get a little more detail on what we've been doing on the Labs2Zero front with some new releases we've just had in May, and sort of give you a little bit background on the project and program as well. So if we go to the next slide. So again, what we'll do is I'll give a quick overview of the program, sort of give you a basis again of what we're doing, some of the different elements and components. It's a little bit of what we've been doing in terms of the progress on that. Then I'll turn it over to Alison. We'll get into more detail on some of the different features, what is available now in the tools, and also give a little bit of a preview of what we're working on now in terms of upcoming tools. And then we'll have some time for Q&A. If you have questions, again, we have a little Q&A at the bottom. Just feel free to put your question there, and then we'll answer them at the end of the presentation. So go to the next slide. So again, we're going to go through an overview. And again, why are we doing this? What's the purpose of the Labs2Zero program? And it's really to help address lab decarbonization. How can we accelerate decarbonization of laboratories? And the reason, obviously, is we're dealing with severe climate change. We need to address that. I mean, some of the things that I sort of came on my radar and I thought was pretty, I wouldn't say impressive, but sort of in a negative way, was the aspect of the Canadian fires. So I don't know if you may have heard a little bit about it, may have seen been subjected to some of the smoke that came down from Canada in the US here, or experienced it in Canada if you're up there. But we had severe issues there. Literally the amount of forestry that was burned was equal to the size of Washington State, about 71,000 square miles. Literally about 5% of Canada's forest area was burned. And then you can see in the graph on the right, that's more than 6 times the long-term average of what typically happens. So very significant. And obviously, if you're watching the news, we've had lots of floods, hurricanes, tornadoes, 100-year events, 500-year events seem to be happening every few years. And obviously, June, even this month, we had significant heat. Last year, obviously, you can see what the statistics on Phoenix. So, looking at, we'll see what happens this year, but last year, if you notice in the graph on the lower right there, that if you look at the worst, highest, hottest months over time, the last 2 months, the July and August of last year, were the hottest on record, even by a significant amount. And one of the statistics I heard recently was that they have estimated, looking back over the last 150,000 years, and in that period of time, they feel last year was the hottest year in those 150,000 years. So it's not just in the recorded history, it's beyond that as well. So obviously we're dealing with something we have to take care of, have to address. And looking at laboratories, go to the next slide, labs are obviously an important aspect of this issue. Labs obviously are very energy intense. We all should know that. But if you look at the estimated amount of emissions for laboratories compared to commercial buildings as a whole, our estimates is that it is around 5% of U.S. commercial building emissions. So it's a significant number. It's a significant amount. And if we don't address it, because many times people look at labs and say, they're just too complex, too many safety issues, we'll deal with office buildings first. Well, we have to deal with labs, because if we don't deal with labs, it's going to become a much larger percentage of the carbon emissions, and a significant factor that we have to deal with. So we need to accelerate this process. We need to decarbonize laboratories. So if we go to the next slide. So what we've put together is this program we call Labs2Zero. It builds on some existing tools, which is the lab benchmarking tool. To that, we've added energy and emissions scoring, similar to what's used in Energy Star, but more appropriate for laboratories. We're developing a certification program for those scores. And then we have these 2 reports we call the AIM report and the Design2Zero report that we'll talk more about. And lastly, we have an accreditation program and training program that we'll be adding. So if you go to the next slide, what I'll do is go through a brief overview of each of these, and then again, Alison is going to talk more about what we've achieved to date. Now, again, the LBT, or the lab benchmarking tool, a little jargon for that, is literally the world's largest lab energy database. It's was jointly developed with the Lawrence Berkeley National Labs. You can go online; it's free to use. You can sort of benchmark your laboratory against other labs, or you can just use the tool to see how other labs are performing. We're excited to see that ASHE, in their ASHE STARS program, has recognized it as an energy performance assessment method. So you can get credit for putting your data into the lab benchmarking tool in terms of the ASHE program. So we're excited about that. To go to the next slide. So the next part of the program is the scorecard, is the energy and emissions scorecard. So we just released a pilot energy score back in October of last year. So again, a 1 to 100 score, similar to what you'd see for an Energy Star score, basically the same methodology of a percentile-based score. And again, it's something where you can now see how your lab performs compared to peer labs with sort of a number. So you can see whether you're in the 80th percentile, or you're better than 80% of the labs out there, or your average at 50%, et cetera. And again, another development there, we're excited that GRESB, which is one of the ESG rating services, has recognized the energy score as a recognized energy rating. So if you indicate that you put your data into and gotten a score, you can actually get credit for that in the GRESB rating system. So we're excited about that. Also, we just released an operational emissions score. So that just happened last month. It's a location-based emission score. Again, Alison will talk more about that. And lastly, we have an embodied carbon benchmarking capability, which is the first of its kind for any type of building, for that matter. And that was just released last month as well. So, and obviously, we're working on a score similar to what we have for the emissions and energy scores. Next slide. So again, one of the bigger developments that we're currently in the middle of right now is the development of the AIM, the Design to Zero reports. These are automated reports that will basically give you a list of measures, energy conservation and emission reduction measures that will allow you to see which measures apply to your building based on your climate, your situation, your types of research, et cetera, and indicate the sort of rough savings of what those measures would provide, what would be the rough costs of implementing them, what would be the then return on investment for that. And included in that would also be relevant case studies. So if there's projects that have been done in the past that are similar to yours, we will then provide effectively a curated list of case studies or reference projects that would allow you to see where else this technology or approach has been used before. Right now, we're currently working on a sort of a pilot, which will be focused on existing buildings. So it's basically the AIM report. Design to Zero report is based on new buildings, new designs. That we'll be doing next. But right now, we're focusing on existing buildings and also focusing specifically on energy measures. And again, we'll add emission measures next. But we wanted to get something out this year so people begin to look and see how it works, get some feedback. And again, the whole point of this is to help build that business case so that when you look at your different buildings on, let's say, a campus, whether it's a university or a pharmaceutical or another government type of campus, if you look at that buildings and you want to get an assessment of what those buildings are in terms of their opportunities and where you'd want to start first, this is where these reports will help you. They'll help you understand which buildings have opportunities, so that at a very low cost aspect, so you can inexpensively find out where you want to apply and focus on, and then with that, then get the funding to have like a level 2 audit or get into more detail on implementing those measures. So this is sort of that first step to get you to the point where you know where to proceed. So we think this is going to be very helpful and reduce some of the barriers to what prevents people from doing some of these projects. Okay, next slide. So once we have that done, then the step after that, which we hope will probably start sometime in 2025 next year, will be a certification of their scores. So people will be able to get recognition for those scores. This would probably be a sort of a lighter type of certification approach, probably similar more to what you'd see for like an Energy Star certification, not a heavy duty certification like a LEED certification, much simpler, basically validating that the score is correct. looking to make sure that the building is running in normal operation, not sort of abnormally, which might have affected the energy usage in a way that's not appropriate. So that's basically what we'll do for certifications. And then on top of this, we also want to do training and accreditation of people related to the program, so you know how to use it, but also how you can decarbonize buildings and give people accreditations for that, as well as accredit people who'll be able to do the certifications. So that's the whole program in a nutshell. If you go to the next slide. We do have a lot of people working on this, so we appreciate all those people that are volunteers that are working on this. We have about 100 people, actually over 100 people that are on various committees, technical advisory councils, or TACs as we call them. We have groups working on the energy score, working on the operational emissions score, the embodied carbon scoring and benchmarking, as well as just the LBT, the lab benchmarking tool itself, and enhancements to make that easier and better to use. And lastly, we have a larger group working on the assessment and design tools, which is, again, the AIM and Design to Zero reports. And there we have people focusing on sort of a baseline model of the building, so filling in, making assumptions about the building where people have not put in information. Group working on sort of the measures themselves and the calculations of the savings for that. Another group's working on installed costs. And lastly, we have a group collecting case studies and helping to curate those case studies so we can then match them up with potential savings measures that people might be looking at and employing. Again, we're still looking for more experts and people to get involved with these TACs. So if you're interested and would like to participate, we'd love to get you involved. So there's still some room on some of the different committees. So love to get your input and a review of the stuff we're doing. So happy to get involved with that. So feel free to contact myself or Alison or Kathleen about that. Next slide. So none of this would have been possible without our founding sponsors, our Labs2Zero sponsors. So we're tremendously grateful for their support of the program. At the diamond level, we have Alexandria, we have Acuity and cell signaling technology. At the platinum level, we have Siemens and Millipore Sigma. We have an international partner, which is SLCAN, who will be implementing the program in Canada. So we're glad to have them involved with the program. Next slide. And then we have our gold sponsors, again, quite a few people involved in supporting it at that level, as well as at the silver level, the silver sponsors. So you can see we have quite a few people, really a broad cross-section of the industry, from owners to engineers to consultants, architects, manufacturers. So we're really pleased to have a broad support across the sort of lab community that's supporting the program. Next slide, please. So lastly, for those people that are entering data into the LBT, the lab benchmarking tool, which again is very important since this is sort of a crowdsourced approach. It's a peer-to-peer type system. So when people put in data, it's anonymized and then added to the database. And that's very helpful to us. So we'd like to recognize those people that are doing that. So if you're an owner entering data, or if you're a consultant, architect, engineer that are putting in data on behalf of your client, I would love to recognize you for that, indicate that you're, a Labs2Zero partner, as well as promotional partners. We're recognizing, obviously, organizations that are helping to promote the program. So we'd love to promote all of you. And as this is coming together, we'll be, doing various things to recognize those participants in the program who are entering data into the system. So with that, I'd like to turn it over to Alison, who's going to get into more detail on the program itself and some of the recent releases we've had and what features and capabilities it can provide you. So turn it over.
All right, thank you, Gordon. That was a really good overview of the program. Now we're going to be able to get into some of the details. We often talk about, the fact that we're looking ahead to a lot of these exciting features coming up for Labs2Zero, but the fact is now we've actually released quite a lot of these tools that you can use today. So this what you can do today section of our presentation just keeps getting longer and longer. And so there's a lot of things that you can now use, which is super exciting because a lot of these things you simply could not do before for lab buildings, and in some cases for any kind of building until we release these features. So the things we're going to focus on are the lab benchmarking tool, which has always been the only meaningful way to compare lab building energy performance. We've got some exciting new features in that, including embodied carbon benchmarking. And then we're also going to look at the Labs2Zero scorecard, which is honestly a better way to compare lab building energy performance now that the scores are available. The exciting part there is that we now have operational emission scoring alongside our energy scoring, as Gordon mentioned. So we'll start by talking a little bit about the lab benchmarking tool. So we gave it a new look in late 2023. It looks much cleaner and more modern now, but it's still the great analytics tool that's built on top of a database of now more than 1,100 lab buildings. The way you use this tool is to use it as to benchmark by filtering. You use the filters to slice and dice our data set of 1,100 buildings to select buildings that are nominally like yours. You can then compare them on the basis of a number of metrics. So if you're looking at EUI or any other type of metric that we have in there, we have something like a dozen different metrics that you can compare the buildings on. The tool, as always, is completely free to use. Our LBT software developers, KW Engineering, want to give a thank you to them for all of the excellent work that they've contributed over the years on it. And as you already saw in one of Gordon's slides, you can access it at the URL at the bottom of the page, and we would very much encourage you to do so. So the way the benchmarking works in the lab benchmarking tool is benchmarking by filtering. So I'm going to give you an example. So say you have a biochemistry pharma R&D building in Nice, France, very nice place to be doing pharma R&D. And that building has 40% lab space by area. So the way that you would benchmark this building against its peers is something of an iterative process. You'd say, okay, I'm going to select all the other buildings that are biology, chemistry, a combination of bio and chemistry. I'm going to select buildings in the same climate zone, zone 3A. I'm going to select buildings with similar percentage lab area, and I might use some other filters as well. But so I get to the point where I select a peer group. In this case, it's a peer group of about 47 buildings. I see that my building here is 7th out of 47 in terms of site EUI, which is good. That's really good performance. And 47 buildings is a reasonable size of peer group. Now, if I'd gone and selected tighter filters or more details, I might have ended up with a peer group that's too small. I might have had to iterate this a little bit to get a reasonable size of peer group, but it's still a really powerful way to be able to get a benchmark in a custom way against other buildings in the database. So Climate Zone 3A, as you saw, has a decent number of buildings in our peer group database. 5A is actually our richest data set. That's because it's got Boston and Chicago and some other major metropolitan areas in there. And we've got a pretty decent spread of data from a lot of different climate zones, though there are a few that are not as well represented. So this is going to come up again later as well. The particularly cold climate zones are not as well represented. And then we have some gaps that are typical of zones in the US Southeast as well. Looking a little bit more across the database, you don't need to look at these pie charts in detail. The main message is that we do span a lot of different lab types, organization types, lab use types. So our largest groups are higher education, although we do have a pretty significant slice from pharma and biotech and some other industries. We have a pretty significant slice from federal government as well. R&D is the largest use of lab buildings that we have. It's about 2/3 to 3/4 of the buildings in the database are R&D buildings, but we also have teaching and manufacturing buildings represented. And then in terms of lab type, in terms of the type of research that's conducted in the facilities, we have the largest proportion of chemistry and biology facilities. They account for a little over half. And then we have a good chunk of physics and engineering as well, and then a few other combinations and a small slice of vivarium facilities as well. These pie charts are actually not the most up to date. They're before our most recent peer group update, but they're still pretty representative of what we have in the database. So you might ask where all of this data comes from. And the answer is the data comes from users like you. So over the years, as users enter their lab buildings into the tool, we review that data, or LB&L staff review that data on a periodic basis. We do some basic QC on the data to check that it looks like real buildings with reasonable data. We then anonymize those buildings and add them to the peer group database that you can slice and dice to find your peers. At this point, as of a couple of years ago, we accept buildings from anywhere in the world, not just in the US. Our data set has grown substantially since we started it in 2002. Most of the data in the database is actually relatively new. Quite a lot of this data will be people going in and updating buildings that were already in there. So even though it looks like a building might have been added in 2010, somebody might have come in and more recently updated the data. So it's more recent than that. We got a really nice bump just recently between 2023 and 2024 here. That's people logging in, putting in their data and getting their energy scores. So we're really excited to see that there's a lot of interest there in getting energy scores and in entering lots of new buildings. We don't have a lot of buildings yet from non-US facilities because we only started asking for those a couple of years ago. So we'd really like non-US facilities to keep adding data so that we can build out the breadth of our data set. So when you start using the LBT, it can seem a little bit overwhelming because we ask a lot of questions on the buildings. There are more than 100 questions we ask for every building that you enter. The really important thing to know is that most of these are optional, and there's only about a dozen actual mandatory entries that are marked the normal way for mandatory entries on websites. And if you've got the data available, it only takes about 15 minutes per building to enter your data and to get your scores. I2SL has put out a nice 2-page quick start guide for getting your energy and operational emission scores by entering the minimal amount of data into the LBT. It's linked from this link that I'm showing here. And that's a really nice, quick way that you can get your data together and be ready to enter it and get a score really quickly. So we definitely encourage you to take a look at that. So that's where the LBT is at for right now. I'm going to talk now about the scorecard. So Gordon's already talked a little bit about our scorecard. It's super exciting because there isn't really anything like this for lab buildings, or in fact, if you start counting the operational emission score for any kind of building that's out there. As of today, we have 2 of these scores available. We launched the energy score in October 2023 and the operational emission score in May 2024, so just last month. If you want to see your building scores and you already have data in the LBT, then you can do so right away. You just need to log in, go to the Your Buildings tab, and the scores are shown right there on the main table summarizing your building. You can then click on the building details button to see more details about your scores, about your energy and operational emissions intensities, and also to see performance over time. So if you already have buildings in the LBT, your scores are already calculated. You don't have to do anything. You just have to go and look for them. We've also calculated the scores for all of the other buildings in the database. So if you go and look on the benchmarking page, you'll see that there are gray dots that all have energy scores and operational emission scores calculated. These are all the anonymous peer group buildings. So you can see what their scores are too. You still can't see what their identities are. They're still anonymous buildings, but they're in there so that you can compare your scores with those of the others in the database. Another cool thing we added to the tool just recently, just in May, was the ability to set yourself a target energy score and to figure out what your energy use intensities would need to be in order to meet that target. So you enter the minimal pieces of information that you would need to calculate an energy score for the building. And then this nice little tool, when you hit calculate, will spit out those target EUIs that you need to meet in order to achieve that score. We're going to be adding something similar for the operational emission score at some point, but for right now, this just covers the energy score. This is a tool that's really useful for buildings that are still in design, for example. If you're designing a building, you've got some energy modeling data, and you want to be able to achieve a certain target energy score, maybe 80 or something like that, you can see what EUI thresholds you're going to have to meet in order to get that score. So now, let's talk in a little bit of detail about where these scores came from, because I think that's important for understanding what it is they're actually showing you about the buildings. So we're going to start with the energy score, even though we've already talked about that and we already released it back in October, but a lot of the stuff that went into the energy score also goes into the operational emission score. So it's really important to explain both pieces of this together. So for all of our score development, we worked with the excellent staff at Lawrence Berkeley National Lab in California. We worked with Josh Case and Travis Walter to do a lot of this data analysis and score development. And for each score, we established goals. What was it we were trying to do with the development of this score? What do we want the score to be able to do? So the important things for the energy score were that we really wanted to automate that benchmarking process. So in the example I showed you before, that lovely building in Nice, we had to take this iterative approach to select a reasonable size of peer group to compare the building against. And that also has this danger where if we update the peer group, then that peer group might change and your benchmark might change. And so it's not really static, and it needs this iterative approach. It needs this engineering judgment. And so we wanted a way to kind of get around that and give something that's just like a one-stop, here's your benchmark, a nice static way to be tracking your performance over time. We also needed it to be fair as far as possible. So we needed to account for the fact that labs are not all the same. We definitely know that, you know, a physics teaching lab on one side is not the same as an intensive chemistry research lab on the other. So we needed to account for those different requirements between lab buildings. We needed to be simple as possible. And we wanted to use it so that users can understand their energy performance and they can be encouraged to improve that performance. So with all that in mind, we took the following approach. The approach is pretty similar to that used by the EPA for generating Energy Star scores. So if you're familiar with how that works, then it's really very similar to that. So we used a statistical approach, in this case, using our LBT peer group database of about 1,000 buildings to develop the rating system. So we do this by developing a rating system that adjusts for the different functional requirements of each lab building. And that's based on what we see in the data in terms of functional requirements affecting the energy consumption of lab buildings. So to make that a little bit clearer, I want to use one example of a functional requirement, probably the biggest one, the most significant one for us, which is the amount of lab space in the building. So you might expect that the amount of lab space within a given building would drive the energy consumption of the building. A building that's only got 15% lab space, you probably would assume it wouldn't consume as much energy as a building that's got 60% lab space by area. And you'd be right in general. So this chart on the right shows a lot of lab buildings where we're plotting the source energy use intensity against the lab area. And you can see that there's a clear trend there. So buildings with more lab area as a percentage have a higher EUI than buildings with less lab area. So lab area would be considered a functional requirement of the building. So that lab space is something that the building has to provide to its occupants in order for them to do their work, in order for the building to fulfill its needs. It's also something that we don't really want to penalize for. We don't want to directly compare a building with a small amount of lab space with a building with a large amount of lab space. So we want to adjust for the amount of lab space in the building. So in that sense, the amount of lab space gets something of a free pass. You know, you're not going to get penalized for having more lab space in your building. So a lot of the discussions in the score development were about what constitutes a true functional requirement. What are the things that we should be adjusting for, correcting for in our scoring system? Things that are not functional requirements would be cast more as a question of optimization. So it's not a functional requirement, but it's how the building chooses to meet its functional requirements. And you wouldn't want to correct for those things, because those are the things that determine whether the building is doing a good job in terms of efficiency or not. So there's some fairly clear functional requirements. So we already mentioned lab area. Others could be the occupied hours of the building, ventilation requirements, geographic location, probably. And then there are some that are clearly not functional requirements. So for example, the HVAC system design is not, building envelope design is not, energy management practices also not. And then there's some things that sit in something of a gray area. So, you know, number of fume hoods is a pretty classic one here. Do you really need all the fume hoods you've got? Lab densification is another one. You know, do you really need all the lab space you've got? So there are definitely some gray areas here where we had a lot of pretty lively debates in the TAC and with our LB&L colleagues about this. Another thing that was really important was whether we had any data on these parameters or not. So in order to adjust for a functional requirement with this statistical method, we have to have data on that functional requirement within our database. And it's just kind of a feature of making questions optional, is that people don't answer those questions. So we have less data on the fields that are optional input fields in the LBT than the ones that are mandatory. So you can see here, we're highlighting the difference in the amount of data we have, lots of data on the number of fume hoods, but not so much data on the occupied required air change rate in the building. So for some of these fields, we'd love to use them, but we simply couldn't because we didn't have enough data on them. So long story short here, we took a list of candidate functional requirements, we ran them through the statistical analysis, and we ended up with a list of fields that had a statistically significant relationship between the value of the field and the energy consumption of the building, and where we had enough data to make it useful to make that comparison. These, just for your reference, are the regression parameters. We have a white paper that's linked from the site that has all the details on this, and we're not going to go into it in any more detail for now. However, I'm going to show you an example of how the scoring system works. So say we have a building What we do in order to calculate its score works like this. We start by allocating it its allowed energy use intensity. We begin with a base allowance. We then add adjustment factors based on the occupied hours of the building, the amount of lab space in the building, the weather experienced during that period, and then some stuff about lab type. Here we have an adjustment because the lab is biology or chemistry versus physics or engineering. And when we add up all of these adjustments together, we come to the total allowed energy use intensity of the building. We then compare that to the actual EUI of the building and take the ratio. So in this case, the actual consumption is higher than the allowed consumption. The ratio is 1.3. And then we take that ratio and we convert it to that 1 to 100 score. So this basically works by saying that 78% of the buildings in our database, our peer group database, have a better performance than this. They have a lower energy ratio. And that means the energy score is going to be 100 minus 78, which is 22, which is not a very good rating. So if you're at 1.3 times the allowance, your energy score is going to be pretty low. So that's how the energy score works. I want to move on now to talking about the operational emissions score. We similarly started with goals, working with LB&L. The goals that I want to emphasize here that were different from the energy score goals were that we wanted to make sure that the operational emissions score was complementary to the energy score. It wasn't just a rehash of the same thing. It wasn't going to give you exactly the same number as the energy score did. We also wanted to make sure that we were recognizing and encouraging beneficial electrification with our operational emissions score. We were very excited to produce this score because really, nobody else has done this, never mind just for lab buildings. People haven't really done this for other types of buildings either. And we really feel that it gives this complementary view that really you can't just be looking at energy alone. You really do need to be looking at emissions as well. So we had a number of decisions to make as we were going through the score development process. We decided that we wanted it to look a lot like the energy score in terms of its formulation. So we wanted it to be a 1 to 100 percentile score. We wanted to compare it to our LBT data set, use that rich data set that we have. We wanted to correct for functional requirements, much as we did for the energy score. We wanted to make sure that this applied beyond just the US, that this could be used throughout the world. It was very important for us to include district energy emissions factors here because the fact of the matter is that almost half of the buildings in the LBT are on district energy of one kind or another because a lot of them are on campus energy systems. So it's really important to handle that properly. At the same time as deciding that all of these things were required to be included, we also decided to not include some things in our first version of the tool. So these included non-energy emission sources, fugitive emissions, and process emissions. And that was largely because we don't have any data on those. So we can't do a statistical analysis on those. We'd love to include them in future. So we are now collecting them via the LBT, but they're not included in the score formulation. A really big decision for us, though, was looking at the reporting method for operational emissions. So this is typically reported in two ways, usually as a pair, location-based and market-based emissions. So location-based emissions are based on the electric grid that the building is actually connected to, the emissions factors for that grid, whereas market-based emissions include all that, but also include market-based purchases of renewable energy credits, power purchase agreements, green tariffs, and all that sort of stuff too. So both of these are really important, and they're two good complementary ways of looking at operational emissions. However, we only had the data to allow us to calculate the location-based operational emissions at this point. And so we made the decision that for our score, for our pilot score, we were just going to include location-based operational emissions, and that we'd be looking at market-based emissions later. So to jump to the answer here about how the score works, I'm going to show you the same example as before. So this is exactly the same as I showed just a couple of minutes ago. This is the example for the energy score where we had that building that ended up with the ratio of 1.3. Where we go to calculate the operational emission score for this building is we take that allowed EUI for the energy score and we convert it into an allowed greenhouse gas intensity. That factor was calculated based on what's typical for the buildings in the database. So once we have that allowed greenhouse gas intensity, we then compare the actual greenhouse gas intensity to the allowed. We get a new ratio, which in this case is 0.6, which is pretty good. That's better than 76% of buildings in the database. And so the operational emission score for that building is 76. So the building ends up with a pair of scores, energy score of 22, not very good, operational emission score of 76, pretty good. That happened for this particular building because it's not a very efficient building, so it gets a low energy score, but it is sitting on a low intensity, a low greenhouse gas intensity electric grid, so it gets a pretty good operational emissions score. So that is how that works. So we're in a pilot phase for both of our scores. We're collecting data to try to help us assess how well our scores are working. We're also collecting feedback from users of the scores. And lots of people have been interested in trying this. I think I already mentioned that we saw a bump in data entry. So more than 200 people have created new user accounts on the LBT since we launched the energy score. And we've also had more than 250 new or updated lab buildings added to the tool, which is really exciting. You know, that's more than we normally see in a given year. We're very excited by the amount of energy we're getting, the amount of feedback we're getting from the community. So we're going to use all that feedback and all of that data we're getting to update our energy score and take it out of pilot mode once we have enough data. And at some point, we're also going to introduce a market-based operational emissions score once we have enough data on that as well. We are still looking for feedback and more data. It's very easy to provide that. All you got to do is enter your data via the LBT, view your scores, and then send us an email and let us know what you think. We do know that there are some places where the scores still need improvement. So you'll see in the LBT, you get a little warning triangle if we believe that your particular building might have an inaccurate score for one reason or another. Particular places that we're looking for more data are vivarium-dominated facilities, manufacturing facilities, prime labs, and then labs in very cold climates. And by cold climates, we mean ASHRAE climate zone 6 or above. So if you're sitting there in Northern Canada, we would love to get your data. Okay, so that's the scorecard so far. I want to move on now to talking about another really exciting thing we did with the lab benchmarking tool in May. And that's the question of embodied carbon benchmarking. So embodied carbon, of course, relates to the emissions associated with the materials that are used to construct buildings. And they make a really significant contribution to the overall global carbon emissions, about 11% of the total at the moment. So just as with energy consumption, there are good reasons that lab buildings' embodied carbon content might differ from that for other kinds of buildings. So, for example, lab buildings might have more stringent structural requirements to limit vibration or to support extra equipment loads. So it's really important to look at lab buildings in some detail. And it is worth doing all this because we can actually reduce embodied carbon emissions if we try. Reductions of 40% are feasible today, so there are very good reasons to be benchmarking and taking action on embodied carbon in lab buildings. So that's what we decided to do. And it's not something that had been done before really for labs or for any kind of facility. So we decided to approach this in a two-step process. Step number one, to set up an embodied carbon benchmarking site for lab buildings. The spoiler there shown by the check mark is that we just did that. And step number two was to create an embodied carbon score for lab buildings. Both of these steps need actual building data to do it. So we've been working hard to collect life cycle assessment data from our community to get these efforts started. That data is anonymized and it's used to seed the benchmarking database. It'll also be used for score development. And to keep things manageable, we've been focused on the biggest components. So we've been looking at the building structure and enclosure, and on the product stage, A1 to A3 of the life cycle. We've collected a really nice chunk of data, but we do need more. So please do let us know if you have any LCA data that you can share. You can now enter it via the LBT, as you'll see in just a second. But it's really crucial for us to get more of that data. So the LBT now includes embodied carbon benchmarking. This was a big deal because we had to change a lot of the ways that the LBT worked to accommodate data now from buildings that are not only in operation, but could also be in design or construction. And you'll see that as soon as you go to the LBT, because the first page you get when you enter a new building asks you whether your building is in design or whether it's an existing operating facility. It'll also ask you whether you have embodied carbon data or energy data to share, or both. And then if you say embodied carbon data, we've got these new pages that will ask you for LCA information, structural information. We try to limit the number of fields we ask, just again to keep things manageable and also to focus on the most important factors when we're looking at embodied carbon. We also added a dedicated embodied carbon benchmarking page. So this works the same way that the old energy benchmarking worked, where you use filters to slice and dice the data set of peer group buildings to select buildings that are nominally like yours, maybe the same design phase in this case, maybe the same vibration criteria. You can then compare the embodied carbon intensity of those buildings with each other. We only have 30-something buildings in the peer group right now compared with the 1,100 buildings we have for energy. So we'd like to get more data, as I mentioned. So please do enter more of your LCA data via the LBT if you can, so that we can help build our benchmarking database. All right, so that's all the stuff you can do today. And as I mentioned, it's a lot. We have released a lot of tools. We've gone places that no one has gone before, and we're really excited about that. But we're still excited about all the things that are coming. And the big thing that we're working on this year, as Gordon mentioned, is the AIM report. So just to get into slightly more detail on the AIM report, as Gordon mentioned, it is essentially an automated ASHRAE level 1 sort of screening level audit of your lab building, based on all the data that you've entered in the lab benchmarking tool and using an energy calculator to recommend the best measures for your building. We are hoping that the first release will be later this year. We are planning that it will be later this year. With that release, we're going to be focusing on existing buildings, so not new construction buildings, and also on the energy measures. Again, as Gordon mentioned, not specifically looking at emissions measures yet. We've been working really hard on this. We started with some early site mockups here that we've been showing. We've now got some real professional site mockups that were created by our software developers. So things are moving along with our software development. But it is a really large project. So as you heard already, we have 4 different TAC groups working on this in an advisory capacity. We also have some very major engineering contributions that are being made by Bureau Happold and by Smiths Group. So thank you very much to both of those companies for their expertise on that. And we have 2 different software developers working on the project as well. So it's a very large team and it's a very large effort pushing this towards our pilot that you should look for it later this year. As you already heard, we are still looking for more case studies. So the AIM report is going to showcase relevant case studies for each of the measures that it highlights. We are still looking for case studies to share. This is a great opportunity for your organization or your company to showcase their achievements, their products. So I would definitely encourage you to submit your case studies to I2SL so that they can be displayed on the AIM report website and everybody can share in learning the lessons that you have learned and can see how successful you've been with your projects. So please just let us know. In a couple of slides, there's contact information. So just let us know if you've got any case studies that you can share. All right, so we're getting pretty close to the end of the formal presentation here. So I just want to summarize by saying that we firmly believe that Labs2Zero is addressing the urgent need for lab decarbonization that Gordon described at the start of the presentation. We've produced, to that end, a first-of-its-kind scorecard for the energy and emissions performance of lab buildings that now has energy and operational emission scores on it. A little later, we'll be adding embodied carbon and market-based operational emission scores to that. We've started the first ever embodied carbon benchmarking site for lab buildings or potentially any buildings. And our release later this year of the AIM report is going to take that next step to bridge the gap between just assessing performance to actually improving performance. Perhaps most importantly, Labs2Zero has been an enormous community effort. So I do want to reiterate the big thank you to everybody who has served us in various ways, serving on our TACs. There are still opportunities to join the effort, to get involved. As Gordon mentioned, we are looking for more volunteers to join TACs. We would love to get more information as you pilot our scores. We're definitely looking for more building data. We're looking for those case studies. And of course, if you're interested in sponsoring, we still have sponsorship slots available. So with that, I'm going to leave up our contact information, these ideas to get involved. And I'll pause now, say thank you for your attention and see whether you have any questions for us.
Thank you, Alison and Gordon, for that great overview of the progress that's being made to Labs2Zero. We do have some questions that came in on the Q&A. First of all, how do we know if our company has previously inputted data into the LBT? Do we search by company address?
Right. Yes, I'll take that one. So that is a good question. So one thing to mention is that the anonymity of the data submitters to the LBT is very important to us. And so we don't make that list of data submitters public. The first thing that I would recommend you do would be asking around at your company to see if anybody has been entering the data into the LBT. The other thing we can do for you is if you want to submit a custom request to us, we can look up in the database to see whether somebody from your organization has been entering that data, and we can probably help guide you to who the right individual would be at your company. But we don't make that public. It's not a publicly searchable database because, you know, the anonymity of our users is very important to us and to the whole operation.
Great. Does the tool have radiological labs as an option?
Yeah, we don't specifically have radiological labs as an option. My suggestion would be if you have radiological labs, that you just attempt to classify whether they are more physical science or biological science, you know, depending on what you're using those for, and then just classify them that way. If you do feel like we don't represent your lab type accurately within the LBT, then we do have a free notes field in the tool where you can enter a note saying, my labs are really this or this or this, and it doesn't really match up, but this is what I did. And we will see those notes as we're working to improve the tool. So leave us a note. But the best thing you can do in terms of your data being useful to you and to the tool in general and to the effort in general is just to pick the closest match to what you have. The problem with choosing other is that other always gets thrown away, you know, because we don't know what other is. And so it's not really a good category. So yeah, just let us know if something's missing, but just, you know, make your best guess as to what the, use your judgment, I should say, as to what the closest match is within the options.
And then how would you classify a lab used for nature conservation work?
This is, I suppose, a similar answer to the previous one. You know, is this a biology lab? You would say it's a biology lab. If it's research that's being done, it's research. And then leave us a note if it's really something that's truly functionally different from what you would, from what we have within the tool. But most likely this is going to be biology and R&D.
All right. And then also, if we do need more vivarium facilities in the LBT, what portion of a lab building has to be vivaria in order to count as a vivarium in the LBT?
Yeah, good question. So within the LBT, what we ask for is the individual space areas of different types of lab space. So physics, chemistry, biology, vivarium, makerspace, and other. So whatever area of vivarium space you enter will be taken into account in our data analysis. But we then use that data to automatically classify a building as biology, chemistry, biochem, vivarium, or anything. And so in order for it to be classified as vivarium facility, I believe it's more than half of the lab space in the building needs to be vivarium space. But the individual percentages are also recorded and stored and are used in the data analysis as well.
Okay. And then there is a comment here about that Carbon Leadership Forum is working on some embodied carbon data work as well.
Yeah.
Is I2SL working with the Carbon Leadership Forum on its embodied carbon score in any capacity?
Yeah, I can take that. Yeah, definitely. We're in communication with them, and in fact, one of the things that we recommended to them is to add a lab category, because what Carbon Leadership Forum has been doing is not as much benchmarking, which is what we're doing. They've done more studies and sort of basically collecting data from the industry and then providing reports as to what's happening in terms of embodied carbon. So it's more of a data collection and reporting exercise, where what we're trying to do is give people the capability to put their data in and then see where they stand versus others. So it's a little bit different approach. But we are working together. And as I said, one of the things that we saw on their study, the first study they did, which was a few years ago, was they didn't include labs as a category. It was just part of other, which is not very helpful, obviously. And so we've encouraged them, which they then, in their second study, which they just completed and getting some results out now, they did add laboratories as a category in their study. So now we can get data that we can compare to our data to see how we're both collecting information on laboratories. So that's they're a great organization, and we're happy to have been involved in working with them on this aspect. So yeah. Thank you.
Thank you, Gordon. We do have a question, and it goes back to some of these things about lab space and the use of space. Do we have to separate out office and lab space in the data that we submit, if the two types are in the same building for our company?
Yeah, I can answer that one. And yeah, I mean, the answer is yes. So, I mean, almost every lab building also has office space in it. And the really key thing about reporting data to the LBT is that we're asking for lab space area, as in net lab space area within the building. So probably the data entry field that we provide most guidance on is this one, because I know that for some other reporting systems, it means something different. But so if you have a lab building that is just, a lab building that is a research lab building, it definitely doesn't have 100% lab space. What we're looking for is the actual net lab area within the building, which is typically not more than 50% of the space within the building would be actual lab and lab support space. So you definitely do have to report the amount of lab space. As you saw, it's a very important driver of the energy usage of the building. So it's a very relevant parameter to provide. You don't need to split out office space or conference space or corridors or anything else specifically. You just need to specify the part of the building that is actual lab and lab support space.
Thank you, Alison. Are Scope 3 emissions, which can be quite high in some lab environments, going to be included in the emission score in the future?
So I'll answer this for the operational emissions side. The answer is probably not. We're not at this point. It's not on our roadmap to be including Scope 3 emissions on the operational emissions side. But Gordon, maybe you want to take that for the embodied side.
Well, embodied carbon is a little bit different. I mean, that's, a lot of times someone considered a Scope 3 emission. So, I mean, what we're looking at for embodied carbon is, sort of right now it's the cradle to grate, which is really the product side. I mean, sometimes people will put in other aspects of Scope 3. Can be travel and other pieces that can be transportation from, the equipment to the site. Right now, we're not including that. I mean, we are collecting some of the data on those aspects of the life cycle. But right now, we're just focusing on the sort of A1 to A3 and focusing on the building superstructure. Probably the next thing would be would be interiors, which is still an emerging area out there in terms of data that people have. But the goal will be to include that in the future. And we are collecting data on that on an optional basis. So we can sort of see what's out there and begin to see what we can do in the future to add that capability. But that's the focus really now is not as much on the things like travel or stuff like that or transportation. It's really focusing on the materials themselves.
Thank you, Gordon. This is also related to embodied carbon data. It may be a little bit individual to each person's situation, but who are the best respondents to the embodied carbon data to be entering into the data? Can the engineering and architecture firms do this, or general contractors? And do general contractors generally have the skill sets and incentives to respond accurately?
Yeah, well, I'll take that. So I think the answer there is both. I think one of the things that's important to know when you're looking at embodied carbon is there's, just like in energy use, you've got sort of design and you got actual practice. When it comes to embodied carbon, what that represents is the design. So the architects and engineers are basically creating a design that has a certain amount of embodied carbon predicted based on using certain materials and things like that. And that is one set of numbers, and we're sort of collecting that set of numbers. The other set of numbers is the in construction, because when you actually go to build a building, now it's the real building. We're on a certain site, and we've got to get low, we got a high fly ash concrete. Well, turns out the supplier that we were thinking we were going to get it from is now out of that amount. We have to, buy it from 500 miles away, which is uneconomic. It doesn't make sense. So you end up, not using that material that we thought we were going to use. So the actual in construction numbers can become different. And it's important to sort of log that as well. Just like we have predicted energy and you have actual energy, same thing is true of embodied carbon. So the GCs are the right ones to enter that in construction because they're the ones actually buying the material. They know what really happened. And again, there's obviously, as with any new thing like embodied carbon, there's a various learning curves in the industry. We've seen some contractors that are very up to speed on this and are very knowledgeable about embodied carbon. They're looking to that for their clients, and they're buying low carbon materials as best they can. and understand what that is. And those are people can very easily enter the data they have into the lab benchmarking tool for embodied carbon. On the other side, you've got the engineers and architects who are designing these and are building, designing low carbon facilities, and they have that data too. So really both have that. Obviously, some groups in both camps, aren't as proficient in this area, but there's that proficiency is growing, and more people are realizing the importance of this and are doing better and designing better low carbon facilities. So, yep.
Thank you, Gordon. Are the inputs of areas gross or net square feet / meters in the LBT?
Yeah, so it's a little bit of both. So we do ask for the gross area of the building in square feet or square meters. You can choose your unit system within the LBT. For the lab space, it doesn't make as much difference, but it is net square footage of lab space or net area of lab space within the building. We do also ask for the total net square footage of the building if you have that and want to enter it, but that is an optional entry, whereas those others I mentioned are the really key mandatory ones that we're going to be asking for.
Great, thank you. I think that's all the questions we have, although there were a few questions about whether this presentation is going to be posted on the website. Not the slides themselves, but the recording of the presentation will be available on the I2SL website, probably in the Labs2Zero or webinar section. Within the next probably day or two, we can get that up. And what I will say is, if you are interested in either giving having a few slides of your own, or more likely to have Alison or Gordon give a presentation to a group that you think needs to hear this, contact me or them, and we'll see if we can set something up. And as Alison mentioned, we are still looking for case studies and would love to hear from any of you who'd like to be a part of the AIM report. So here's our contact information. Thank you, Alison and Gordon, and everyone who's been working on the Labs2Zero program, and to everyone who attended today.